So inverses are the same steps as when we did them with rational functions and logs and exponentials. Replace f of x with y, switch x and y, and solve for y. Those are the steps. Forever and for always. Unless, like, if you're just given x's and y's, you can always just swap them. But here, these are your steps to find inverse algebraically. The thing that we're going to do here is that cosine, to undo cosine, we're going to use arc cosine or cosine to the -1. And you can't, again, those are interchangeable, and you can write either one. I will probably write, I don't know, cosine to the -1 just because that's a little, I don't know, it makes more sense to me to write it that way when we're undoing. But it's up to you if you like arc cosine, if you like doing two C's right next to each other. Yeah, that's perfect. So let's do the math first. Let's do the algebra. We're going to change f of x to y. Y equals -3 cosine of x plus 2. Switch x and y. This is the part that hurts my brain. Because the y so does not belong there, right? And then solve for y. So what am I going to move first? Subtract the 2. Hey, show the steps. Not so much for me, but so that you don't make a mistake. Not that you would ever make a mistake. And then what do I move? -3 divided by -3. You can leave that -3 on the bottom. That's fine with me. If you want to switch all the signs on top, that's okay too. Okay, how do we get y all by itself? Yeah, so not really multiply, but yeah, we have to take the cosine inverse of both sides. We have to use inverse cosine on both sides. It's written like multiplication. So why did we go through all of the effort of restricting cosine and to a little sliver and flipping it? Because we've got to be able to undo it. Just like addition and subtraction are a pair, and logs and exponentials are a pair that undo each other. Cosine has to have something to undo it, or we can't get to that variable in there. So that undoes it. And that's your inverse. So I'm going to write it now as f -1 of x. Okay, now let's talk about domain and range, and then I'll look at the picture. So here's what I like to do with domain and range, and I hope that this is helpful. So we need, of this guy, we're going to do domain, and we're going to do range. And we know with cosine, both domain and range are going to have brackets, right? We just need start and end, start and end. So our domain of our inverse is what of the original? The range of the original. So our original cosine function, think about it, and this is why we're doing this after we did graphing, sine and cosine. So this guy is moved up to, with a vertical stretch or an amplitude of 3. So if we go up to 2 is our midline, and we go up 3 from there, what's the top going to be then? 5. And we go down 3 from there, what's the bottom going to be? -1. So the range of our original is -1 to 5. Again, that little detail is why I moved this unit here. Everything else we could have done another time, really, right after the unit circle. So the range of the original is what of my inverse? domain. So I always go and get that range because since we are graphing masters now, that's not so bad. Dealing with the range of the inverse, I look at if there are any y changes in this guy. So usually for cosine inverse, we're going from 0 to pi, right? That's our parent function range goes from 0 to pi. Is there anything on this guy that does a vertical stretch or moves it up or down? Any number out here? Any number out there? So the range here is going to be 0 to pi. Because there are no changes to, like, we have cosine inverse and then a bunch of stuff in here, right? But all the stuff in there is just horizontal stuff. Nasty horizontal stuff. But it's horizontal stuff. We're not making any changes to the y's. We're not doing a stretch vertically or moving it up or down. And if we had anything out here, we would have to deal with that. Yeah?
Why is it pi instead of 2 pi?
Because if it was 2 pi, it would fail the horizontal line test. So our original would. So we had to just 0 to pi. It gives us that like funny sliver where we have positives and negatives. So let me graph you and show you that you're right here. I'll graph this range and show you that you're right here. So cosine inverse, I guess I could pick up my key. I like made myself extra notes on domain and range today. Okay, whoops. I guess I can do it from here. Cosine inverse of, we just left it as x minus 2 over negative 3, right? I need to go to my keyboard because that's going to be hard though. Okay, there it is, right? So let's look at these points here. We should be going from 0 to pi. We should be going from negative 1 to 5. That's what we said, right? Oh, look at that. Cool, huh? And there's a point in the middle here at 2 pi over 2 that you can't really see. I should just put these graphs on your paper for you so you don't have to. Let's see, that was what, 5 pi? So that's that graph. You don't have to graph it again. I'm not going to ask you to graph on the test. I do think it's good as we're working through examples to double check your domain and range with the graph. Desmos gives you nicer, a little nicer than your graphing calculator, although we are going to be working it. Good so far? All right, let's do some more algebra. Get ahead of me a couple steps on this one. Find the inverse. The range on this one is tricky. The range on this one is tricky. again doing cosine?
Wait, why are you saying negative, like 11 and
Because the negative in front of the cosine. Gotta move that one first. How are we moving the cosine? Inverse, not dividing, right? Gotta do the opposite operation. And opposite operation for cosine is cosine inverse. The opposite operation for ln is 3, right? Just like to talk about logs every once in a while. So you remember that they're a thing. Remember how logs are a thing? Could there be more negatives in that problem? I don't think so, actually. I guess we could have had a negative y. Should have just done it.
can't you be like negative, negative, negative? And then that would still be negative.
Yes. So there's our algebra. That's the majority. If we're talking about quiz points, there's the majority of our quiz points. I want you to be able to undo it. Now let's talk about domain first. And then we'll do range. So domain of our inverse is the range of the original. What up here is affecting the range of the original? Just the -3, right? The flip doesn't affect our distance or amplitude, so it doesn't affect that. It's just that -3. So what happened is our cosine graph got moved with the midline down to -3. What's the amplitude of it? It's 1. So from -3, we're going up 1 to -2 and down 1 to -4. So there is our range of the original. It is -4 to -2. So that becomes the domain of our inverse. Lovely. So with our range of our inverse, usually the range of our inverse, first, this is cosine, is what? Zero to pi. Yeah, usually we're looking 0 to pi. Remember, range is just like your outputs or your y values. So usually we're looking 0 to pi. Is anything here affecting 0 to pi? Is anything here on the outside of the function? Yeah, that -1. So -1 is just down 1. So here's how I would write it. 0 minus 1 would be -1. Pi minus 1 I would write as pi minus 1. I would just write it as pi minus 1. You're going pi units down 1. That'll get you the exact value. So down 1, you're just going to subtract 1 from each. If it was a horizontal, like if we were doing a vertical stretch by 2, we would just multiply them both by 2. If we were if we had a 2 out front of that cosine. So it'd be 0 to 2 pi. If it was a vertical compression by 1/2, you just multiply them both by 1/2. This is the hardest thing, is the range. Really good. All right, let's see one more. Hopefully it's a sign. Oh yeah, okay, it's just not. Did you want to see that graph? Did you want to check our domain and range? Okay. It's pretty. I'll show it later. I looked at it earlier today when I was studying.